Hello and happy Tuesday, my friends. My name is Danielle Carter, and I'd like to welcome you back to another insightful episode of Cisco Champion Radio. Today, we are calling out our wireless enthusiasts. This episode is about all things wireless, from the beginning to where it's headed, and we are joined by Matt Macpherson, who is the CTO of Wireless over at Cisco, as well as our Cisco Champions. So let's get started.
Hi, I'm Michael van der Roest. I'm a senior network engineer at the Dutch Air Traffic Control and also a CCIE, and happy to be here today.
Hi, I'm Tony. I'm Tony Dawes from Egypt and working as cybersecurity for a company, Wadi Degla Holding. And I'm about 13 years in field of cybersecurity. And I am pleased to be here.
Hello, Sebastian Kozankiewicz. I'm voice and network architect in Norma Group, and I have responsibility about everything about the network topic, WAN, LAN, wireless, also the topic about the security.
And I'm Dan Jones. I'm Solutions Engineering Director at Hamina Wireless. We make Wi-Fi design tools.
And I'm Matt Macpherson. I'm happy to be here to have this conversation with the champions today. I'm in the wireless CTO over at Cisco. I cover things like regulatory, what's going on in the standards, and especially that next generation. So that's what us CTOs like to do, is talk about the future. But we'll get into several of these topics, I think, today, as we have a chance to communicate a little bit about where Wi-Fi is and where it's going. Sure.
It'd be good, because you're always forward-looking and future-looking, where have we come from before we get to where we're going?
Yeah, you know, it's interesting. I can remember the first time I ever did wireless. It was very simple. I don't even remember what generation it was. But I could go out on my back porch and get my email. Mm-hmm. And I thought, wow, look at this. You know, I'm not bound to my desk. Now, that was a long time ago. You can see I have a little bit of gray in this beard. I was younger then, but it's come a long ways. Let's not go back too far, but let's start with Wi-Fi 5, because, you know, Wi-Fi 5, it's still 40-50% of the deployments that are out there today. So what did we have with Wi-Fi 5? Something that was very successful. It's deployed almost everywhere. It's hard to go into a building that you don't see Wi-Fi. But with Wi-Fi 5, you know what we did? We really over-provisioned the network, and we under-subscribed it. And then what did you guys do as the experts? When the subscription started going up and it started getting busier, what did you do? You added more capacity. And then we did things like radio resource management, and we increased AP density. But that's what we did with Wi-Fi 5, and it was actually quite a bit of work, especially as more and more traffic, people, devices, started to go onto the network. In comes what? Wi-Fi 6. So we go into Wi-Fi 6, and we made a fundamental change. We enabled something called OFDMA. So without getting into all the acronym soup, what it basically means is now we could schedule in the frequency domain as well as the time domain. So now we could have multiple devices talking at the same time, right, while looking for that next transmission opportunity. Do you know what other major technology is based on OFDMA? Cellular, right? You're absolutely right. So what's happened is that these industries have learned from each other. And we've made improvements in Wi-Fi based on the expertise coming from the cellular market. But you know what cellular is also doing? They're coming in and they're doing private Wi-Fi and these types of technologies. And so guess what? They're learning from the Wi-Fi community as well. So we go into 6, 2 things. OFDMA, that frequency division. And again, there's a lot more there, but I'm just taking a very high, very probably oversimplistic view, but just to get a little bit of that history. You also enabled the ability to schedule from the network. So instead of this controlled chaos that we had kind of in the early days, what would happen is that things would listen and they'd start talking, and then if it was busy and utilization went up, you'd collide. When you collide, things would back off and they'd try to transmit again. And as utilization got very high, what would happen is that Wi-Fi would perform worse and worse and worse, and you'd get this long tail latency.
It's like a snowball effect, doesn't it? The more retries, the more collisions.
Exactly right, because if 2 things are colliding to get on the network and they both back off, something else could try to slip in. Now there's 3 things colliding on the network, and you can see where it goes from there. But, as you go into Wi-Fi 6, now the network can actually say, okay, you talk, now you talk, now you talk. And that's a much higher capability when it comes to control. So 2 big things, OFDMA and the ability to schedule from the network. And then 6E, in the US, 1200 megahertz, in Europe, 480 or 500 megahertz, depending on what country we're talking about. There's nothing, it's hard to name a feature that's quite as dramatic as adding a big chunk of spectrum.
Yeah, more spectrum, more space.
More spectrum.
That's helpful, yeah.
Right, and there's a lot of reasons, and we'll talk a little bit about that. And then what? Wi-Fi 7. Wi-Fi 7 comes into play, and now we're talking about determinism. Determinism. I remember the first time I ever said determinism, I was on stage, and we took some questions afterwards, and some guy got up at the microphone, and he goes, "You can't do determinism in unlicensed wireless? Are you crazy?" So that's what I was told, right?
Yeah.
And so what are we doing with Wi-Fi 7? We're doing things like multi-link operation. We're increasing the reliability of the overall network. We're managing that spectrum much better. And now we're working on Wi-Fi 8, which takes it to the next, really the next level. So it's exciting, I think. It's exciting to see what's going on in Wi-Fi. There's a lot of development that continues to happen. I always said that you'll never be bored if you work on wireless technologies. It's always quite the challenge, but it's a lot of fun, and it keeps on changing. But I know that you have a lot of questions, so why don't we go ahead and we'll start, and we'll do a couple of questions from you guys, and we'll dig in and we'll see where it goes.
Okay. For example, how? Because previously the Wi-Fi 5, if people invest the new access point, they can install it, and it was installed for the years, like 10 or something like that. I remember like a few years ago, one access point stopped working because certificate was expired, was installed only for the 10 years. And now we have the Wi-Fi 6, Wi-Fi 7, maybe next year Wi-Fi 8. How company can protect the investment? Because previously it was designed for the 5, 6, 7, 10 years. And now 2, 3. How we can solve the problem like that? Because the company don't want to spend, I can't go, okay, please give me a few $1 million, I want to invest in new Wi-Fi, and next 2 years, okay, this is the old device, please give me another millions.
Yeah, it's something that we continue to cycle on. What's interesting is when I first got into networking, the recycle time on networks, because there was so much development going on and so many new features, it was actually closer to 3 years.
Yeah.
I think it's actually spread out now. It's gone to 5, maybe a little bit more. Cisco's always been, I think, exceptionally good at this because they continue to support their product. Even after end of life, they continue to support it for years. But it's always something that I think as a vendor that we have to struggle with a little bit, because if we don't do the latest features, the customers say, "Why aren't you doing the latest features?" And if we do the latest features, then the customer says, "Hey, you're forcing me to buy a new network." So it's a little bit of back and forth, I think.
Yeah, and I think also, especially with Wi-Fi, the main thing has been there was a relatively low adoption rate, right? So that there were very few clients on the network. So it did last longer because there were fewer clients on there. Whereas nowadays, Wi-Fi tends to be, and wireless in general tends to be, the primary access method to the network, right? So every new thing that comes into that network normally is actually connecting wirelessly. And so, for me, that's part of why that ramp up happens as well. It's not necessarily just the features, it's about all the new clients that are coming into that space as well. And you don't need necessarily all the latest features, but by having them, when those newer clients come in 2-3 years' time, now you're set up ready to go again for that kind of next round as well. It's funny, previously, before I was here, I worked for an MSP, and one of the questions we would get all the time was shall I wait for Wi-Fi 7? Shall I wait for Wi-Fi 8? Just get the thing that's available now, because that will set you up for now. You don't have to replace it when 7 or 8 comes out, right? Build what you've got for now, sweat that as long as you can, and then upgrade when you're ready and just get whatever's new then.
Yeah, we actually see that quite a bit. Chances are, if you're still on 5, you'll probably go to 7.
Yeah.
If you did the 6 upgrade, or if you're into 6C, you're probably not going to do another upgrade till 8 or 9. So you can jump the versions, just like you mentioned. So that's pretty common behavior. Now in security security is a little bit special, right? So when you start running into some security issues, we do a pretty good job. Cisco has a lot of effort into making sure that those are identified and that we can offer the software fixes as quickly as possible. And we have an entire organization just looking at that. But in some cases, getting to that next level of security also requires some changes in the silicon and how we're doing some of that. So it does end up pushing you into that next release. I'll say one thing that's happening, and I hope we get into a little bit of this conversation, is that what we're seeing in the development of the standards is that there's less happening in the lower layers and more starting to happen in the upper layers. So there's more tied to the functionality in Wi-Fi 7 and 8 as we go forward, to the ability to do software upgrades to those capabilities than before, where the dependencies were absolutely down in the silicon. I'm not willing to say there's no dependencies on silicon, because if you do things like change channel width and things like that, there's a silicon dependency. But a lot of these features that we're seeing for handling things like latency, for doing capabilities around ultra reliability, those are actually a little bit higher up in the stack, which is good because that means you can build some longevity off of that as well.
Does that mean then that you're putting a lot more compute into those APs and things as well, right? To handle all that software side of things?
Yeah, that's a really good question, because it happens in a couple of places. One is you need more compute. Two, you need more memory, right? And three, if you're watching our silicon friends, what's happening is that we're starting to see inference engines go into these chipsets themselves, so that you can now let things like AI play, what I call play its position. So there's certain things that you want to do out at the AP because it's time sensitive, and then there's certain things that you're going to want to do more at the switch or the WAN connection, and then there's certain things that you're going to want to do in the cloud. And so those architectures are starting to come out. But it's interesting, there's not a single silicon vendor that's not putting some of that capacity into the next generation chips. What does it mean? There's going to be more compute, call it GPU. There's a lot of different names for AI processing now, but more GPU that's going to go right into that distributed device.
Nice. How AI will help in Wi-Fi technology to get better and easier for work and for home?
Yeah, so AI falls into multiple different categories. So what I would say is that AI, sometimes I think people think that, AI is going to solve all my problems. Right, and I don't want to say AI is going to cause new problems,
Yes,
but it can, right? So there's a trust factor too, depending on what we're talking about. If we're talking about things like agentic AI, where the AI starts making decisions and configurations or changes to your network on the fly, well, that's a little, maybe I want that, maybe I don't want to turn that on right now.
You've got to be a special kind of person to allow that to happen, right?
Yeah, it's interesting because, you have these self-driving taxis now, right? And what's the first thing that you think? When one of those pulls up,
Amazing.
Do I want to get in this thing? Well, that's an AI, right? And I think it's the same thing when you're managing the networks. But I will say this, AI is not going to change the laws of physics. But the way I look at AI is that it can implement optimizations in the network much faster than a human can. So in other words, as opposed to collecting a lot of data, you or an IT administrator then looking at that data, trying to figure out how to optimize the network, pushing a new configuration, seeing what happens, and coming back. Now we can be much more agile in how we do this. And we're starting to see that in some of the next generation functionality and capabilities, and spectrum optimization is one of them. When we talked about previous generations of Wi-Fi, we would often say, we're putting faster cars on the road. And then we said, we're adding lanes to the highway, right? So when I think about AI, what I think about is managing the whole traffic system, right? So think about a city and all the traffic that's going on. You have the underpasses and the overpasses, and you have the intersections. Now, when I say that AI can make decisions very fast, let me give you an example. How many of you pulled up to a four-way stop? Who goes first?
Whoever's bravest.
Yeah. In some countries, whoever hits the horn first, right? But in typical fashion, who's ever got there first, right? Mm-hmm. Now, I live in North Carolina. Those folks tend to be really polite. And so we pull up to a four-way stop, and everyone's waving at everyone. Oh, you go. And they go, oh, no, you go. But there's always somebody that came from New York, 3 cars back, and they're hitting the horn. Yeah, but I mean that's human speed, mm-hmm. right? Humans have to get to that intersection, and then when you get to that intersection, you have to make a decision, and then it goes. But think about AI. Why have a stop sign?
Yeah.
If you have the data and you have the cars coming, no one ever stops. They slip between each other, mm-hmm. right? And it's completely optimized, right? So think about a highway. A highway is the amount of cars that can go on the highway is based on how fast our reaction time is, mm-hmm. right? So if the AI is optimizing that, what that means is that we're getting higher efficiencies out of the spectrum that we have, mm-hmm. and the ability to move packets. So that's what AI is really going to bring. It's going to give us that capability to design to what I call the best case. Mm-hmm. So RRM, everyone's done RRM on their network, okay. right? Radio Resource Management, right? So in RRM, what do you do today? You measure, and then at 3 o'clock in the morning, when you don't care about knocking everybody off the network, you change your power plan, you change your channel plan, mm-hmm. right? Mm-hmm. That's the way that you do it. And what did you just do? You measured over a week, a month, or whatever amount of time so that you could figure out what your worst case is, and then based on that worst case, you set your channels and you set your power levels. What if we used AI to, instead of designing the network for the worst case, we design it for the best case? Mm-hmm. What if we actually recognize the current RF conditions on your network and where the heavy load is, and we moved the spectrum there? This is some of the things that we're working on in Wi-Fi 8, where what we can do is we can actually increase channel size based on utilization. So if there's a particular portion of the building or stadium or theater or whatever that's using a lot of spectrum, you can say, well, I'm going to raise that up to 160 megahertz channel. Yeah. And I'm hardly doing anything over here at this particular point in the day, so I'm going to reduce that down to a 40. Mm-hmm. And then the system can breathe, right? And the AI RRM can actually be adjusting to how people are moving through the building. Yeah, we talk to a lot of venues. If you have a big football game in a stadium, and then the next week you have a concert, totally different RF characteristics. Yeah. Don't we want to be able to tune to that in real time and optimize it? So I would say that we're not going to change the laws of physics with AI, but what we are going to do is really optimize our ability to get packets on and off to in the network, while maintaining latency and jitter characteristics that we need for these next generation applications.
Cool. Do you then think with AI you can get to the cellular level of connectivity? Going back to the concert where you have the Wi-Fi and you want to stream live, it doesn't work. Hey, 5G, it does work. And that kind of is like a strange thing as a network engineer and gluing like, oh, this is all Cisco, why doesn't it work?
Yeah, when you run into some of those problems, that's the question. It's the first thing. Anytime that you're at a public venue and something doesn't work, the Wi-Fi is broke. You ever notice that?
Oh, it's always the Wi-Fi. Oh, yeah.
It could be the backhaul, it could be the authentication, it could be any number of things.
DHCP normally, yeah.
Right. I would say that in Wi-Fi, what we're doing is we're extending the toolbox to increase not just the throughput. Throughput is almost an old thing now, right?
Yeah, I agree.
But to increase the reliability, the resiliency, the ability to schedule traffic in such a way that we can handle everything that's thrown at it. RF is fickle. You go into these stadiums and we tend to do a lot of special things, because when you're doing that radio resource management in your enterprise space, what are you doing? You're saying this AP is going to be on a different channel than this AP, because if they're on the same channel, then they're contending. and you don't want them to contend. And we often do a reuse factor somewhere between 6 and 12. The problem is that when you go into a lot of these big public venues or a stadium for a sports or something like that, is that it's open. And because it's open, the RF propagates.
Yeah.
And so you end up seeing a lot of other APs that are on the same channel as you. Now, there's a lot of ways to deal with that. One is you throw a lot more spectrum at it, which we kind of did in 6 gigahertz, but I think we're finding we're consuming very fast. Or you can get smart about it. And so what we do is we'll do a flat panel antenna and we'll start to reduce the aperture. And so what we do is we shine the RF into different places in the stadium or in that big venue, especially when you have high ceilings, think 10-meter type ceilings.
Yeah.
You want to be able to shine that down because otherwise, if you're using an Omni, it's going to propagate in every direction and everybody's going to be interfering with everyone else, which is exactly what you don't want to have happen. So we'll shine it down, we'll do beam forming, and so with those types of technologies, we can get a much more resilient result. So Wi-Fi, it's interesting because you can, especially when you look at the later specs, the number of features that are optional versus required for certification is shifting quite a bit. There's quite a few features that are not mandatory anymore. So people can put a stamp on an AP and say, I'm Wi-Fi 7, and only do a portion of those capabilities. Of course, when you're doing an enterprise class or a service provider class implementation, what you want to do is implement those other features so that you get that good end result. So that's what we're doing. So the answer to your question is, can you deploy a bad Wi-Fi? You can. Can you deploy a good Wi-Fi? You can, because we have a much bigger toolbox than we've ever had before, and that's what we're doing. And by the way, I hate throwing rocks at Wi-Fi because it can be very simple and just use a piece of the stack. There's a reason that light bulbs will go on Wi-Fi but not 5G, because there's a lot of IPR associated with 5G. There's a lot of complexity associated with 5G, so you don't see light bulbs on 5G. But when you put a light bulb on it, it doesn't have a real sophisticated stack either. So you could say that that's a Wi-Fi weakness, or you could say that that's a strength because it goes both down and up market.
One of the things I've noticed recently with APs, they tend to be getting a lot more radios, right? So like recently we had ultra wideband was added in and things like this. Where do you kind of see that going? Are you seeing the AP as almost being like the hub of wireless and not just Wi-Fi?
What a great question. And it's complex. So, and I'll tell you why. So APs today, everybody thinks AP, they think Wi-Fi, but it's actually a multi-radio platform.
Yeah.
So take a Cisco AP, right? So Cisco can do the .11 stack. It can do 15.1, otherwise known as Bluetooth. There's others, but mostly Bluetooth. There's 15.4, so think things like Zigbee, Thread, Matter, some of these next generation IoT technologies. You brought up ultra wideband.
Yeah.
All these things are in the mid-band. We do a GPS too, for figuring out where the APs are. So they become these multi-radio platforms. So when we think about radio resource management today, we're almost always talking about Wi-Fi and how the channels are going to work, because Wi-Fi tends to be heavily utilized, carries a lot of traffic, and has a high expectation, not only on throughput, but the latency characteristics and what we call determinism, or getting to those next generation applications that require a deterministic or predictable result. Now, there's other technologies that either they propagate further, they're less demanding on battery, that are IoT technologies that are also going in there. Now, what happens when these different technologies start all using the same spectrum? Well, then they start knocking heads, right? So there's a big, I was gonna say fight, but when I see people yelling in standards bodies, that usually means it's an important issue. And eventually cooler heads prevail and we get to a good end result. So right now what's going on is that there's a lot of worry about what's going to happen in the next generation between Bluetooth and Wi-Fi, because you're going to have these Bluetooth systems, and these Bluetooth systems tend to be peer-to-peer. Now, if there's RF going on in the same channels that you're using for your Wi-Fi network, what does the Wi-Fi community call that activity?
Interference.
What?
Interference.
It's interference, right? If it's another AP and another management domain, what do we call it? We call it a rogue.
Yeah.
Get rid of that rogue device, right? Rogue sounds bad, right? Because it
is.
End result, it is bad. But then when you start moving between stacks, now how do you manage that? And the way that we do that today is we have a contention-based protocol, and we do this thing called listen before talk. But you know what Bluetooth does? Bluetooth is this narrowband frequency hopping technology. So it's here, right? It's here. Oh, then it's here. Oh, it's here. It's here, right? And so what's the Wi-Fi trying to do? With its new toolbox, it says, oh, I'm going to do puncturing. Oh, I see some interference here, so I'm going to puncture a hole there. It's not there anymore. It's over here, right? So these things, so they have to be able to contend in a way that is compatible with each other. And so what's happening is there's a big effort going on called coexistence.
Okay.
And what we're doing in coexistence is we're taking infrastructure-based implementations, like you're used to with your APs, that will look across the different radio utilizations, right, and then actually manage those. So what you could do in a situation like that is say something like, you could broadcast, hey, if you want to do a peer-to-peer technology like VLP, the United States just introduced yet another one called GVP, right? So we have VLP, we have LPI, and we have standard power. Now we have GVP,
okay,
right? So just to keep things interesting.
Thanks.
But when you have peer-to-peer technologies that are out there, that looks like rogue activity. And so we have to steer around that activity. Or, better yet, why do we let it fail? Why should we let it fail and then try to recover? And that's what Wi-Fi 5 really did, right? So if you started getting all these collisions, what did it do? It had recovery mechanisms, back off a random time, transmit again, right? And then now we started putting more sophisticated mechanisms into scheduling. But if I'm scheduling my Wi-Fi, I'm not scheduling the Bluetooth. Right? So then Bluetooth comes in, and what do you get?
Yeah.
Right? So now we're looking at new ways of actually advertising. The AP can say things like, I am going to reserve this spectrum for peer-to-peer. I'm going to be here with my LPI infrastructure network. And so if you don't go here, you won't interfere with me, and I won't interfere with you.
Nice.
Right? And so everybody wins. Right? So what we're trying to do is, to a certain extent, don't get me wrong, I don't have anything against listen before talk, but it's sort of your path of last resort, right? I've collided, now I got to back off and do something, and at that point, latency and jitter becomes unbelievable.
Because all of that now is just wasted airtime, right? It's just
gone. And you're just doing this back and forth. So if you can coordinate that up front, and that's where things are going, and what a beautiful place to do that in an AP that actually has all of those radios.
And it knows everything that's happening.
And it knows what's happening, and so you can manage it. So radio resource management in the future probably won't be a Wi-Fi thing. It'll probably be a cross different stack type of thing.
Nice.
Sounds good.
That was a long answer, but...
Okay.
But for example, when we're talking about this automatic cars, yes, because this car need to receive a lot of signals from the road and the others, and sometimes need to really fast track, so there's no time to transfer this data, I don't know, to the cloud, to AI, need to check it, because sometimes, no signal is the worst which we can receive. And now, what about the AI in the Wi-Fi? Because it should be also inside, maybe not inside the wireless controller, but maybe inside the access point. Because now for the next year, will be a lot of factory and a lot of devices connected together like the humanoid robots. They need to, and in this case also, the Wi-Fi need to react really fast. So also, this will be sometimes no time to transfer this information from this device, access point, wireless controller next to the cloud or something like that.
Yeah, so good point, and that's exactly what I meant earlier when we said let AI play its position, right? Because, by the way, it's not just going to the edge and the access point. There's actually AI all the way into the device. Most of the user devices now are implementing AI engines, right? And so there's collaboration that can even happen between the AP and the device. So the APs are going to do functionality that I would say is going to be more about the immediate radio resource management. But what will happen is that you'll start to go into more and more central locations based on what you're trying to do. So let me give you an example. One of the things that Cisco does, because we do something called device analytics. And in device analytics, the device can actually trigger a condition saying, I'm having an issue, right? So it can trigger an issue, and so it goes to the AP. Now the AP can have an AI. So what's the AP do? It says, hey, is this unique to this device, or is it happening on all the devices that I'm connecting to? Or is it just happening on this brand device that I'm currently connecting to? Or a device that's running this particular version of software or driver, right? And so the AP can then look at its, see, this is what I mean by playing its position. It'll look at its scope, and then you know what the AP can do? It can go up to the switch, or it can go into a core switch. Hey, is this happening across the network? Or is this isolated in this instance, in this particular area? And then when you go into the cloud, what you're doing is you're looking at not only the whole network on a floor, you're looking at buildings, you're looking at campuses. And so what happens is that you get a lot of data that goes into that central AI, and so it's looking at it broadly, and then but when you're down there in the AP, it's looking at its specific environment. Now there might be something that's up in the cloud when it's looking across the whole network, that something is recognized that the AP with a much smaller view into what's going on doesn't see. And so now the cloud-based AI could trigger to collect additional information or captures in order to troubleshoot an issue that it saw by correlating data across your campus, right? The same thing, maybe the AP sees something because it actually is doing the RF activity that the central AI doesn't see, because you can't send everything back, or we use all our bandwidth sending data back, right? And then it'll trigger collection of additional information that's specific to that issue. And so this will be a breathing system, right? That'll move back and forth between the AIs in order to get the best optimization you can based on the purview of the data that you're absorbing and whether you're applying LLM to it or other technologies.
Speaking of which, do you think Cisco will imply that more globally on all portfolios and business units? Because I see where it works.
You mean beyond wireless?
Yeah, well, in service provider, for instance. Or
for sure. I mean, service providers, they're what's interesting about service providers is that they know exactly what they want because it's monetized, right? So I'll never forget the first time I ever dealt with a service provider, again, lots of gray, this is years ago. What they would ask me, and might even have been before Wi-Fi 5, but they would say, well, how many Erlang am I going to get per busy hour of capacity on this Wi-Fi network? And you know what I used to say? I say, well, it depends. How much interference do you have? How many other networks are there? And you know what service providers don't like? It depends. That's not the answer they're looking for. They want a carrier class experience. That's what's so important now. Then with 6, the ability to schedule, and 7, the ability to provide resiliency. Now we can claim carrier class connectivity, again, in a well-designed network, right? Preferably one with a Cisco label. That's using these next generation technologies. Now the service providers can do things like use their identity to extend their network into your guest networks with the knowledge that they're going to get a carrier class experience. So the ability to converge Wi-Fi with cellular or the carriers is better now than it's ever been in the past. And so a lot of the blocks to successfully doing that are disappearing.
Things like the open roaming standard, and stuff like that, it's almost like magic when you use that for the first time, right? And you're just like, oh, how am I connected to this network? And it's just, working. And I think like the work that's been done with education on EduRoam and all that kind of stuff has been kind of really important.
Do you know open roaming is a gateway to EduRoam?
Yeah, exactly. Yeah, that's what I mean. It's great. It works really well. I remember doing some stuff with Wimbledon, and again, like really trying to kind of convince them, hey, open roaming should be the thing that you're kind of aiming towards, because you've got this great Wi-Fi network, you've got all this extra overlay cellular stuff. Wouldn't it be great if it could just be a magic kind of experience between the two? Because they're over such a large campus, right, where they've got indoor space, outdoor space. Wi-Fi can do a great job over a lot of that. But actually, where there are those gaps, wouldn't it be great if there was just a completely seamless?
The way I've always looked at it, because I think these worlds have to. They have to converge. Yeah. They have to. Yeah. There's so much traffic being carried on Wi-Fi, and there's billions of dollars going into Wi-Fi deployments. There's billions of dollars going into what I would call the more ubiquitous umbrella, 5G cellular type deployments, right? If we converge those networks, then everybody wins, right? And so there's a lot of work that's happening there. I don't know that I can mention vendors on this, so I'm going to be a little bit careful, but I'll just say that there's a really popular big device manufacturer that is doing some cool stuff now where they geofence. And basically what it does is that if you, within that geofence profile, you can specify if I've got a private 5G network and I also have access to the cellular public network, and I also have access to Wi-Fi, what I can actually say is instead of being Wi-Fi first, I can go to private 5G. So I can tell it which path to take. Or if I'm in this particular area, go to the public network. Or if I'm in this particular area, go ahead and prefer Wi-Fi. So that's exactly what you're talking about, right? So,
and even down to an app level, being able to say that as well. So this app go through this contention. Go through this connection. This app go through.
Yeah, you should be on the CTO team. It's not there yet. We are doing it for things like texting and voice. Now, generically doing it across the apps, that would be great. It's not there yet, but we're starting. We're going down that road.
Nice. Sounds good. I had a question. Because of the extra compute and stuff that's going into these APs, do you see there being a future where you have some sort of distributed compute across the APs that are there? A lot of the time you might see like an AP that's 10% utilized on the CPU, or it's only using 5% of its memory and things like that. Do you see any future where there could be?
So I just want to be clear, I'm talking about futures now. And nothing that is a committed product.
I'm like poking you,
trying. As soon as I start talking about this, I'll have some PM at that thing slapping me around. You can't talk about it. Yes, because to your exact reasoning, you can imagine that even as we're doing RF and we're moving different channel sizes and how much RF we want to apply into an area, the same is true for CPU and even GPU or the inference engine, right? And so you could do that horizontally to get better effect. But I think that's a little bit further down the road because it's easier to just go to some place where the APs are aggregated to do that than to try to do it distributed. It's like the old distributed database problem. Because when you distribute the database and you have sync things,
you now have an admin overhead,
right?
And that kind of stuff.
Right, but it's possible.
Nice,
it's possible.
How Wi-Fi 7 or 6 being secured in AI technology,
So there's a lot of things that are going on right now around security. Quantum is the one that everyone likes to say.
Yes.
So quantum computing is it's troublesome, right? Because if you have that much compute, then what happens to your keys and how long does it take to actually break a key, right? So here's the good news is that everybody kind of sees this coming. And so just recently there's been new work groups that have been established in IEEE and work that's happening in the WBA and the WFA specifically focused on quantum. So how do we get our networks quantum ready? And Cisco's doing this at multiple different levels. They're doing it in the data center, they're doing it all the way up through the switching fabric and all the way into the AP because you have different potential attack surfaces, right? So you have to be able to handle that and make sure that you can secure every point in the network. So I would say that we're in pretty good shape. We see it coming, and we're working on the technologies to keep us secure, even if you do have that type of capacity. So that's going to be an ongoing development area. I feel like security, I have to admit that I've invested in some security companies because every time you secure something, then some hacker tries to find a hole and you secure it, and then so it's a little bit these types of things because they're finding new ways that you would never suspect, right, to breach some of these things. The same is true when it comes to privacy, right?
Yes.
If you can get exposed to enough data, you could probably figure out who somebody is. And so like security, where you're protecting data and privacy situation, you're protecting identity. So it's the same thing. How do you accomplish that? And so there is a lot of work that's going on in that particular arena.
Do you think that then that's going to be something that one of the kind of great things about Wi-Fi has always been that it's been backwards compatible, right? Do you think that that kind of security angle is going to be the thing that kind of makes people go, okay, we're going to have to call it here, draw a line under it, that's done?
I would say there's probably nothing that causes a customer to desire to upgrade their network faster than security.
Yeah.
I mean, you can talk about bandwidth, you can talk about these other things, but security is one that gets everyone's attention right away. So yeah, I think so. And some of the capabilities will obviously be down in the hardware as well, for various reasons, including speed. And if just like your PC, you can secure a key in an area that the OS can't even get to, right? So there's things that you can do to take that to the next level, and you can do that in APs, and you can do that in the rest of your fabric as well. So I think we've been given the sign. I'll say, any burning last question you'd like to?
I have one really quick. Will we ever see 60 gigahertz in a Wi-Fi AP?
I hope so. I hope so.
Cool.
Again, I always hesitate to mention partners, but we have partners that are interested in going there, and it's very line of sight.
But I think that's a good thing for security and for other things as well, actually.
It is, and so what you can almost imagine, just like 5G is an umbrella technology for Wi-Fi hotspots, you can imagine in a building Wi-Fi being an umbrella technology.
For the 60 gigahertz.
Yeah, for up there in the high ranges. So yeah, I think that's something. It's out there a little ways, but it gets looked at periodically.
Nice.
Good.
Do you think Wi-Fi will ever get rid of its legacy, like the backwards compatibility?
So backward compatibility is a great thing, and it's a terrible thing.
Yeah.
And so when it comes to backward compatibility, what we did in Wi-Fi 6 is we did raise the bar. We said you have to be at least WPA3 capable, right? So there were things that were required when we went to 6. And one observation I know when we were talking before was that when we went into some new spectrum, that was a good place to do it because there were no legacy devices there. So that's good. And we should periodically do that. And I will say that standards bodies and certification bodies like WFA are looking at deprecation, because at some point those old features are just hanging around so that devices that are consuming all of your spectrum are still on your network. And so you just eventually got to kind of push those over the edge. But I mean, look, we're very backward compatible. And there'll probably be a radio picking up all of those devices just for that reason, even if you start putting these more deterministic and reliable radios for the more advanced modern devices. So there'll be a migration path for it.
Nice.
Thank you very much.
Thank you.
For your time.
Thank you.
Well, thanks for the questions. And it's so now are you still glad you work in Wi-Fi?
Sure.
All right. Well, I think that's a wrap. And it's like I said, it's always good to talk to the champions. You asked some of the most in-depth questions that I've had in a while. And it's good to hear some of the feedback, because we always want to make sure that we're focusing our engineering resources in the right direction. So really appreciate you coming out, and look forward to next time.
Yeah, thank you.
Thank you.
Okay. Thank you.